How does an electric motor work? Let's use a typical motor from our model 113 LS motorized pulley to illustrate. When electric current flows through the copper wire windings in the stator, it sets up a rotating magnetic field through the rotor. An induced electric current in the rotor reacts to the rotating magnetic field and produces a force on the rotor, which results in torque to turn the rotor shaft. As you can see here, the Rulmeca motor is directly coupled to a gearbox, and that gearbox, through what we call the end housing spur gear, directly transmits the torque into the pulley shell. And since the conveyor belt wraps around the pulley shell, the shell provides the pull to pull the conveyor through friction between the pulley surface and the bottom of the belt. Now there's a direct relationship between full load current in a motor and the horsepower of the motor, as you can see illustrated here. For example, a 20 horsepower motorized pulley has a full load amp draw of 23.6 amps. You can see 4 models of Model 400 on the left and 4 models of Model 500 on the right, with lower horsepower units on the left and higher horsepower units on the right. A 15 horsepower Model 400 draws less than 20 full load amps, while a 25 horsepower motor draws more than 30 full load amps. Why do we need to pay attention to full load amps? Well, that's because a 3-phase AC motor is not able to protect itself internally. Therefore, overcurrent protection is needed. The motor will continually try to put as much pull into the conveyor as it's asked to do. It has no way of preventing itself from self-destructing. For example, in the conveyor drive we mentioned previously, a 20 horsepower motorized pulley would provide a belt pull of 1,568 pounds at a belt speed of 402 feet per minute. This is roughly equal to 20 horsepower, with a small derate for gear loss. Well, if that same motor was required to draw 2,000 pounds at 402 feet per minute, it would be attempting to provide 804,000 foot-pounds per minute of power, which is approximately 24 horsepower, and it would attempt to draw 30 amps. And of course, the motor is not designed to continuously handle 30 amps because the lacquer, the wire gauge, the paper, etc. are all designed to run at a continuous full load amp of 23.6. That's why overcurrent protection is needed. We hope you enjoyed this tutorial. For more informative tutorials, go to our website, rulmecacorp.com, or please subscribe to our YouTube channel. Thank you very much.